Welcome to Programming Network Applications in Java. In this course, you'll learn to create your own client-server programs that can communicate through a network using either TCP or UDP. We'll practice with some fun examples, and there's even a couple of exciting tasks for you to solve on your own with solutions provided to check your work. Additionally, we will analyze the communication with Wireshark. Let's start and get you ready to build your first network app. In this video, I'll show you how to install all the necessary components for this course. The first thing we want to install is the Java Development Kit. And we'll download that from Oracle's official website. Accept the cookies. Accept the license agreement. And then choose your platform. Mine is Windows 64 bits. Save. And now that's downloading. In the meantime, I'm going to download Eclipse from Eclipse official website. I'm going to download the 64-bit. Just go to Download. Save. And I'm going to speed this up a little bit. Now that these two have downloaded, I'm going to run JDK first. And just go through the installation. It's not too complicated. Pretty much just press Next. Close. And then we can run Eclipse. I'm going to choose the first option here, Eclipse IDE for Java developers. Install. Accept the software licenses. And then this is going a bit slower than expected. But we'll just wait through it. Then accept the certificates. And launch. The first thing we're going to be asked for is the workspace. That's the folder where all of your project files will be saved. Make sure to pick the right folder and then press Launch. This is what Eclipse looks like. I'm just going to close it for now, and then in the next lesson I'm going to run it and explain the basics. In this video, I'm going to show you some basics in Eclipse. If you have used Eclipse before, you can just skip this video. When you run it for the first time, you should choose your workspace folder. Your workspace folder will contain all of the project files, so you want to know where it's located. You can select this if you don't want to be asked again. This is the welcome window. You can disable it by clicking here. And I'm just going to close it. And the first thing you should know is how to create a Java project. So this is the Package Explorer area, and you can just right-click in it and go to New Java Project. I'll name mine Java P, for example. That's not very original, but let's just go with it. Then I'm going to go to the source package and add a new package. Right click on the source package, new package. One tip here, there is a naming convention in Java that says that packages should start with a lowercase letter and classes should start with an uppercase letter. I'm going to call this one just package 1 because package isn't allowed for some reason. And then I'm going to create a class. This is going to be a simple hello world class. The first thing I'm going to show you is how to enable or disable line numbers. You should go to Window, Preferences, and then General, Editors, Text Editors, and here's that option. I'm showing you this because if you're using an older version of Eclipse, your line numbers may be disabled by default. Also, to choose a different font or make your letters bigger, you should go to Window, Preferences, Appearance, Colors and Fonts, and then go to Basic, and then go to Text Font. I'm gonna pick a bigger size and press Apply and Close. Now I want to show you how to import and export classes. You'll need that because I'm going to save the code that we'll create in this course as classes. There are two options. You can export the entire project, just right click on your project and go export, and then when you're importing it, go to this Package Explorer area and click import. And then you'll find your way because it's pretty intuitive. But the way we're going to do it is every time we finish a lesson, I'm going to do this. I'm going to right click on the class, press copy, paste it on my desktop or any other folder, and then I'm going to upload that file, so this .java file, into the lesson. You can import it by just dragging it into your package. Now there is already hello world.java here. I'm going to delete that. And then I'm going to drop the same file into my package. And then that's going to work. Now you have all the tools you need to start this course. See you in your first lesson. Let's start with creating a new Java project. I'm going to go to the Package Explorer area, right-click New Java Project. Let's name it Simple TCP, for example. Open that, right-click on the source package, New Package, Simple TCP, And then I'm going to do a right click on that and create our first class. Our class is going to be called server, and that's actually going to be all the code we're going to need for our server side of our application. Now, I'm going to explain every single line of code we use here in a separate lesson, so if you're familiar with Java, you can just skip that. But for now, I'm going to give you just enough information so that you can understand what we're doing here. The first thing we're going to do is we're going to create a main method. A main method is an entry point to your application, and there's actually a shortcut for this in Java. You just type in main, press Control space, press enter, and there you have it. Next, let's add a try-catch block. A try-catch block is basically a piece of code that Java will try to run, and then if it fails, it's going to go to the catch code. So the way you do this, there's also a shortcut for this. You type in try and then press Control space and then press enter. In the try block, I'm going to call new server. Server is going to be a method, public server, where pretty much all of our code is going to be located. And then if anything goes wrong in this area here, we're going to be thrown to the catch block. And what I want the catch block to do is I want to use this E object, that's the exception object, and I want it to print out what happened. So I want to know what went wrong, and that's what I'm going to get by using this method. All right, now let's focus on creating sockets. On the server side of the application, we're going to have two types of sockets, a server socket and then a regular socket. The server socket is just going to hold a port in the operating system for our application. And here it goes. We're going to use server socket, and then we're going to name it socket equals new server socket, and then we're going to forward the number of our port. I'm going to use 2020, looking into the future here, and I'm going to comment that with opening new port. We're getting this error because we need to import a packet that contains this server socket method, and that packet is java.net. But don't worry, there's a shortcut for this too. You just need to press Ctrl-Shift-O, and here it is, java.net server socket. Now, this second error is because we need to throw an exception here. And we're just going to skip this because I'll explain that later in this explanatory lesson. I'm just going to use this to avoid the markups that Java shows when you have an error like that. All right, here I'm going to say print, or I'm not going to do that. I'm also going to use a shortcut, SYSO, Control-Shift, and there we have system out print line. We're going to print out in the console section that port 2020 has been opened. All right. Now we are ready to open this regular communication socket that I've talked about. We're going to use the socket method for it. So it's going to be called socket. And we're going to use our server socket and then call accept. Accept is a blocking method that accepts incoming connections. And what a blocking method means, it means that Java is going to go through our lines of code, and then it's going to stop at this line, and it's going to say, okay, now I'm waiting for an incoming connection to come up. And it's not going to continue to go through the other lines until an incoming connection actually appears and it is accepted. Let's quickly import java.net.socket. So again, Control-Shift-O should do it. There it is. Now I'm going to print out a message saying client, and then I'm going to add this client's IP address. I'm going to say socket.get init address. Init is short for internet, and what this method does, it retrieves the client's IP address from the socket object. So socket object was created right here when we got an incoming connection that was accepted. So naturally, this object contains information such as IP address of our client. And then I'm going to say client and then their IP address has connected. Now we're going to do something a bit more complex. So we're going to create input and output buffers. I'm going to add a comment here just to separate this section. In this lesson, we're just going to go real quick through the code and then I'll explain the details later. But for now, you just need to know that we need a place to store our data, the data that is coming out of our socket and the data that is coming into our socket. We call that place a buffer. For the input buffer, we're going to use the buffered reader. And we'll import these methods or the packets that contain these methods later. So the buffered reader object is going to be in socket, since that's going to read the data that's coming into our socket. So from the client, new buffered reader, and then we're going to forward new input stream reader. That's going to read data from the socket. So we need get input stream. For our outgoing buffer, we're going to use print writer. We're going to name that out socket, new print writer, and then we're going to forward new output stream writer. So here we are actually writing the data into the buffer, and then we're going to go socket.get output stream. And here I'm just going to add true real quick, and I'll explain what that means later, I promise. The only thing left to do here is to import the packets containing these methods, and we're going to get that by pressing Control-Shift-O. There we go. That's java.io and then all of these methods. And now we've got our input and output buffers, and now we can actually move on with the code. From this moment on, we are deciding what kind of communication we're going to have between our server and our client. The first thing I'm going to send as a server is going to be welcome, for example. So I'm going to use my out socket, out socket print line. So our client is going to receive this. I'm going to comment this real quick. All right. And then when I receive the message back from the client, I'm going to store that in a string object. I'm going to call that message. And I'm going to say read from in socket. All right. Now I'm going to print out this message in the console. It's going to be client says, and then add the message from the client. This is going to be our entire client-server communication for now. So after they're done communicating, the only thing left to do is to close the socket. So that's what you should always do when the communication is over. So once the application is going to shut down, we're going to do socket.close. I'm going to comment that too, or it's not going to be a comment, but rather a notification in our console. I'm going to say socket is closed. So the purpose of these notifications, as I call them throughout this lesson, is to know when we have passed a certain line of code. So if we are for any reason stuck in this line, we will never get to this next line. So if I get a printout, socket is closed, in my console, I'm going to know that Java, not me, that Java went through this line and that everything worked correctly and that now I'm at line 29. So this is pretty much it for the server side. The next lesson is going to be about the client, and then I'm going to do an explanatory lesson where we're going to explain all of these lines of code even further. In this lesson, we're going to work on the client side. Let's create our class by clicking on Simple TCP, New Class. I'm going to name it simply Client. Let's start with adding our main method the same way we did it for the server. So I'm going to type in main, press Control space, and then enter. And then I'm going to add the try catch block. I'm going to type in try and then press Control space and then enter. And then we're going to initiate new client in the try block, whoops. And then in the catch block, I'm going to say ePrint stack trace. We can create our client method now. It's going to be public client throws exception. And in this method is going to be our application. So this is going to be our client side of our program. And the first thing we need to do here is to create a socket. This time we only have one type of socket. So on the server side, we had two types of sockets. We had the server socket and then the regular communication socket. So on the client side, we're only going to have a regular socket. This socket is going to be, we're going to use the socket method again. So it's going to be socket new socket, and then we're going to forward two arguments to this method. It's going to be the IP address of the server and the listening port, so the port number that our server is expecting our connection. I'm going to use localhost since my server is on this machine, and I'm going to use 2020, which we defined as our port number. Additionally, I'm going to press Ctrl-Shift-O to import the java.net.socket packet so that we don't have that error anymore. And I'm going to print out a message in the console saying successful connection to the server. This printout right here is useful to us because if something fails in this line, we're going to be thrown to the catch block. So by reaching this line of code, by seeing this sentence in our console, we know that we've successfully passed this line of code. So this really reassures us that everything went well and that we actually are connected to our server. Next thing we need to do here is create the input and output buffers. Now, luckily for us, they're exactly the same as on the server side. So you can just copy them, but I'm going to type them out real quick. For the incoming data, we're going to need a buffered reader. We're going to name that in socket, new buffered reader, new input stream reader, and then socket get input stream. And then for the outgoing socket, it's going to be print writer, out socket, new print writer. There it is. I'm going to add a comment here just to separate this section, and press Ctrl-Shift-O to import all the required packets. All right, these are the basic requirements for our client-server communication. And now what we need to worry about is the protocol. A protocol is pretty much just a set of rules by which communication between two or more sides occurs. So we need to define who is the first to send a message, what kind of responses are expected, etc., etc. For our simple little program, we're going to have a simple little protocol. So the client is going to connect to the server. The server is going to say welcome. The client is then going to say thanks, and then they're going to disconnect. We've already programmed the server to do all of these things. So it's going to be listening for connections, and then once a connection arrives, it's going to accept the connection, and then right away it's going to send out welcome. It's going to then receive the message from the client. It's going to display it in its console, and then it's going to close the socket. So socket.close is actually the line where we initiate disconnection or interruption of the connection. All right, let's go back to our client. So this is where the protocol actually takes place. First, we need to receive the message from the server. We're going to store that message in a string called message, very original. We're going to read that message from our socket with read line. And then we can display that message in our console. We're going to say server says, and then add the message. Now we need to send thank you back to the server. We're going to do that by using our out socket object and print line. And we're going to say thanks. That's actually pretty much it. So according to our protocol, we need to connect to the server, receive the welcome message, send a thanks message, and then disconnect. So we're going to disconnect by closing the socket, socket.close, and we're going to print out a message in our console saying socket closed. Now I'm going to save this and try and run it and see if it works. First, we're going to run the server. So you run the server by pressing or choosing the server class and then pressing play or run in Eclipse. And then I'm going to choose the client class and also press run. So the program is going to just go through all of the code itself since we've already typed in all the messages that need to be sent. But let's just quickly go over what happened. So in order to switch between console messages for server and client, you need to press this little icon of a display here. So right now we're looking at the server console and we can see all of our messages. So port 2020 is open. We got that right here. So we get that message once we successfully reserve a new port in our operating system. And then when a client connects, we get this message. This is the IP address of our client, 127.0.0.1. That's the loopback address. And then we get client says thanks. So we have read the client's message. But before that, we sent welcome to the client. So this actually happened before this. All right, as soon as these messages were exchanged, we've closed the sockets on both sides. So that's when we got socket is closed message, both on the server and on the client. In this lesson, we'll go back to the code that we wrote in the previous lessons, and I'm going to explain everything again and give you some more details. We're going to start from the server. As I've mentioned before, the entry point to any application is its main method. When you run a program, that's what it will look for. It's going to look for the main method to start executing from. Now, this is a regular main method that you'll be using in pretty much all of your Java applications. And the only two keywords we need to worry about right now are public and void. So main is pretty much always going to be public static void, and it's going to forward string args. This is an array of arguments. And public and void is what we'll need in these lessons. So let me just shortly explain those. We will use public for a method anytime we need a certain method to be accessible from other classes or other packets. And then void means that this method doesn't really return any value. It doesn't return any data. So when you call the main method, you don't need it to, for example, calculate anything for you or print out something for you. You just need it as an entry point to your application. Now, to explain this try-catch block a bit better, I'm going to use an example. In this example, we're trying to divide number 2, or rather the value of number 2 with the value of number 1. They are both defined as integers right here, and that's when we get into the try block. And then this is obviously a comment, and here we define number 1 as 0 and number 2 as 62 divided by the value of number 1, which in this case is 0. So if this could be done, if this was okay, if the value of number 1 was 1, then we would be able to see this printout, try block message. I could have put something that makes more sense here, but let's just go with it. So if this was okay, if this line of code was all right, we would be able to see this. Instead, since this is a forbidden operation, we are thrown to the catch block. The catch block could be made to be much more useful than this. For example, you could prompt the user to insert a different number or something like that. But the point of this example is just to show what happens in a try-catch block. So in this case, we have a print line which says error, don't divide a number by 0. So we pretty much know that the only issue that could happen in this situation is if a user gives us a 0. So that's what we would get, this printout. Obviously, we would skip this printout because this is the line that would cause us to go to the catch block. So once we're out of the catch block, we're going to get another printout that says I'm out of try-catch block in Java. So this is what our output in total would look like after going through this code. Now, we didn't have an explanation like this in our catch block in our program. So I'm gonna change something. For example, in the client, I'm going to try to connect to a wrong port number to see what happens. So we're going to see this print stack trace method in action. I'm going to save this first, and then we'll run the server. And then we see that server is running, port 2020 is open. And now we're going to run the client, and the first thing the client is going to do is it's going to try to connect to the wrong port number. We can see the printout in our console window. I'm not going to go through all of these errors. They're actually all related to the first one that says connection refused. Now, obviously, the connection is going to be refused because in our client, we tried to target a port that isn't open on our listening server. We can close these now. And the server is still running because it never got out of this line. So it's still in this line waiting for a legitimate connection to come in to be accepted. So I'm just going to stop the server and close all of these windows. And then I'm going to change the port number back to 2020, and I'm going to save that. All right, we can move on now with our explanations. As I've mentioned before, when we run our program, the first thing it gets into is the main method. Then we get into the try block where we can see new server. This is when we call this method right here. And then the first thing we do in this method is we create the server socket. Creating a server socket pretty much means that we're going to reserve or we're going to open a certain port that we're going to use for this application. Then we create a regular socket that we're going to use to communicate to the client. We get this socket, or rather this socket can be used as soon as we have an incoming connection that we can accept. So as I've mentioned earlier, this line right here is blocking the rest of the program until an incoming connection shows up. This next line is, I hope, pretty intuitive, since this is just a printout. It says a client has connected, and then we're pulling an IP address from the socket. As I've said before, we use this socket method to create a socket object, and this socket object holds all the information that's relevant to our connection, which means we can pull the IP address of the client from this object. And that's exactly what we're doing in this line, or in this little part right here. All right, on to the buffers now. Obviously, we have two streams of data. We have the incoming stream of data and the outgoing stream of data. We're going to use the in socket for the incoming stream of data. That is the data that is coming from the client to the server. And then the out socket is going to be used for the outgoing data, which are all the messages that the server sends to the client. You may be wondering, why do we need three methods here? For the in socket, those methods would be buffered reader, input stream reader, and get input stream. For the get input stream, obviously we're looking at the same socket in both cases, for incoming data and for the outgoing data. A socket is like a door, so you can come in and you can get out. So by using get input stream, we're selecting the data that we want to look at. Now, this data is going to come in pretty much like gibberish. If you've ever used Wireshark, you know what I'm talking about. So it's going to be messed up. That's why we need the input stream reader to switch that unreadable data into something a user, or a human being in this case, can understand. So that's going to switch that gibberish into readable text. And then the buffered reader, we need that to put all of that data into a buffer. I'm going to use an additional example to explain buffers, and also this example should explain this true argument that we used in our print writer method for the outgoing socket. So this is the example, and this is the website if you want to go and check it out. It simulates an application or two applications that are talking to each other. On the left, we have the sender, and on the right, we have the receiver. The sender wants to send 6,656 bytes of data, but its buffer size, and it's the same on the receiving end, the buffer size is only 2,048 bytes. So we're going to have to send this data in 3 different batches. Or let me check. So it's going to be even more than 3 batches. Let's run it and see what happens. I'm going to press start and then I'm going to press pause right away to explain what's going on. All right, so the sender puts 2048 bytes to buffer. Now, sender's buffer is full and we want to transmit that data to the receiving end. Let's resume. Okay, at this point, the receiving end has received all of this data. So now the receiver buffer is full. Sender's buffer is also still full, and it's going to remain full until it receives the acknowledgement that the receiver has received the sent data. Also, notice that the application hasn't read any data yet. It's still in the buffer. That's because the application reads the data in certain periods of time. So it's not always reading the data. It's not just flowing through the buffer. Application is going to read the data from the buffer only when the buffer is full and when the application actually wants to read that data. Let's see what happens next. We're going to resume and I'm gonna hit pause right here. All right, so in this moment right here, the sender received an acknowledgement that says, we received your 2048 bytes. You can send the next batch now. Now, I'm not going to discuss these windows right now. It just means that the buffer, that the receiving buffer is full and that it can't receive any more data. So this pretty much means don't send any bytes yet. So let's just look at this moment as we have received the acknowledgement. So now that the sender has received this acknowledgement, he or she or the sender, they can now delete the data that was in the buffer and they can transfer another batch of data from the application to the sending buffer. So that's now in the sending buffer. Let's look at what happened in the receiving buffer. The app consumed the 2048 bytes, so the buffer is now empty, and then the next message it's going to send, it's going to say, okay, send the next batch, and this time I have this many bytes available, or I have this much space available in my buffer. Now what happens next is we're going to transfer the next batch of data to the receiver, and then its buffer is going to become full again. And then the application is going to take over that data. Let me pause here to see what's going on. Okay, application consumed the next batch, so it's almost getting full. Now the sender is going to send the next batch. And this is actually an important moment. So the application tries to consume the data. Excuse me. So the application tried to consume the data, but there was not enough data to consume. This means that you can't consume data from the buffer if the buffer is not full. Same goes for the sender side. So you can't really send the data if the buffer is not full yet and there's still some data left in the application. So we're going to have to wait for the buffer to get fulfilled, or to have the maximum number of bytes that it's supposed to have for it to be able to send the data over to the other side of the application. That's actually why we use this true argument here. So because we would normally have to wait for the buffer to be filled in order for the data to be sent to the client, we're going to say true, which pretty much turns on the option of flushing. So this says to the socket, doesn't matter if the buffer is full or not, flush the message, just send it out. And if you've ever used Wireshark, you can just capture some data and you're going to find some TCP packets that have PSH flag on. That's the push flag. It's the same thing as out of flush. Now, the reason why we have to use flush in our program is because our messages are quite short. The server sends a short welcome, and then the client sends thanks, or what was it? Yeah, it was thanks. So we would never fill out a buffer here. So anytime we use out socket, it's automatically going to turn on this push flag, and this packet or this message is going to be pushed out of the buffer even though the buffer isn't filled. In the next part of our program, we are just following the protocol. So connect, let's say this is the client. So the client initiates the connection, and then the server sends welcome to the client using out socket, and then the client is supposed to say thanks back to the server. So when we look at the server, this is where we receive this message. So here we receive, I'm gonna add a comment here, receive thanks. In this case, we know in advance what is it that the client is going to say. So we're going to display what the client said. And then after that, we close the socket, both on the server and on the client. That's this last step, disconnect. All right, let's look at the client then. The only difference between the client and the server, apart from some small differences in the protocol part, is the socket. So for the server, we had the server socket and the regular socket. For the client, we only created the regular socket because that's all we need on the client side. Here we are connecting to the server. We gave the address of the server, and we can use 127.0.0.1 here too. That's going to work also. And we need to make sure that we have typed in the right port number. Let's run the application again to check if it works. So we're going to run the server first, and then I'm going to run the client. And we saw that that works. So this isn't much fun since everything happens on its own. In the next lesson, I'm going to add a prompt for the client to type in its response to the server, so it's going to be more interesting than this. But for now, let's just go through the code on the client side. So we've already talked about the socket. This is pretty simple. Hopefully it's clear enough. And then this is just the protocol part where we are talking with the server. We're first receiving the message from the server that says welcome, and then we print that out in the console, and then in the end we are sending thanks back to the server. After the communication is all finished, we can close the socket. That would be it for this exercise. If there's anything else that maybe is still unclear, send me a message or post your question in the Q&A area. And then in the next lesson, we're going to make this simple program just a bit more complex. It's not going to be much, don't worry, but hopefully it will at least be more fun. As promised, in this lesson, we're going to make our simple little program a bit more interesting. For the sake of keeping our previous code, I'm going to create a new packet. I'm going to right-click on the source packet and go to New Package. I'm going to name it Simple TCP 2, for example. And then I'm going to copy the previous two classes by selecting them, right-click copy, and then right-click on the simple TCP2 package, and then paste. I'm going to close the previous two classes and open the two new ones. The first thing we're going to change is we're going to enable the client to be able to send something custom to the server instead of just saying thanks. We're going to need a scanner for this. I'm going to create a new scanner right here. It's going to be scanner, for example, keyboard, new scanner. And then we're going to use system input. Then I'm just going to press Ctrl-Shift-O to import all the necessary packages. And now we need to prompt the user to type something in. I'm going to say system out, but I'm not going to use print line. I'm just going to use print. The difference is that this one doesn't add a new line after the text. So the prompt is going to say something to the server, for example. And then the user is now supposed to type something in. So I'm going to use the message string. All right, that should be it. So we're prompting the user to say something, to type something in to be sent to the server. And then whatever they type in is going to be stored in the message string. And then that's what we're going to send out. Instead of thanks, it's just going to be message. All right, let's save this and then run it to see if it works. I'm going to go to the server and I'm going to run the server. And then I'm going to run the client. And here we can see the prompt. So I'm going to type in, instead of thanks, let's just say, okay, whatever. I'm going to press enter. And on the server side, in the server console, we can see that this is the message that we've received, and then the socket is closed. That was pretty simple. I'm going to clean this up, and now we're going to complicate things a bit further. What we're going to do now is we're going to play a simple game. We'll generate a random number between 1 and 10 on the server, and then we're going to ask the client to guess the number. First, I'm going to clean up a little bit in the client class. So we're going to need this string. And I'm not actually going to need any of this. So this is where our new code is going to be at. And then I'm going to go to the server. Over here, we're also going to need the string, or are we? We're not. We're actually going to need an integer here. So I'm just going to delete all of this. And I'm going to start by generating a random number. It's going to be an integer, and I'm going to call it secret number. Now, this is just one of the ways you can do this. I'm going to use the random method. What this means is give me a random number out of the first 10 numbers, but always remember that we as engineers, and especially if you're a programmer, you always count from 0. So this would actually return a random number between 0 and 9. So in order to get a number between 1 and 10, we're just going to add 1 to whatever this returns. Next, we're going to use a do-while loop. If you are a total beginner to programming, just a short explanation here, a do-while loop lets you run through the loop at least once. That means we only check the condition to go into the loop at the end of the first run. So you actually have to go through the code at least once to get to the condition. I'm going to say do, and then we're going to prompt the user to guess a number right away. So we're going to use the out socket for that. Out socket print line. And then we're going to send guess a number from 1 to 10. Next, we're expecting a message back from the client. Okay, so it turns out I am going to need that string after all. So the message is going to come through the socket. It's going to be in socket read line. And now let me define that string. All right, so what we have here is the first time we run into this code, into this loop in particular, we are going to send a message to the client saying guess a number from 1 to 10. And then we're expecting a message back from the client where in this message we have a number. So what we're going to have to do is we're going to have to translate that message, which is a string. Okay, as long as we use this read line method, we're going to be getting a string. Now, this is a number, so I have to translate that number from a string to an integer. I'll do this within the while condition. So I'm going to say, all right, now bear with me. Integer parse int message. And we're going to compare that to secret number, but we need that to be not equal to our secret number. Let me try and explain this a bit better. So as long as this condition is met, and this is pretty much saying, okay, so this is what the client is giving us, and as long as they're not hitting the right number, we need to go back into the loop. We need to say guess a number again. That means that they haven't got the right number yet. So we keep sending them the prompt and the opportunity to guess the number once more. For the first time when they hit the right number, so when they type in the exact number that we have generated here, we're going to get out of this loop. When we do get out of the loop, we're going to send out socket print line, you got it. For example, you can send whatever you want. And then I'm going to print out in the server's console, secret number is out, for example, exiting the app. That's hopefully it for the server. I'm going to save this and switch to the client. The client is going to be guessing a number. I'm going to call that user number. And we're going to be creating a loop here too. It's going to be a regular while loop. And the condition is going to be, read from the in socket, read line. And then if that line starts with guess, that means we haven't guessed the number yet and we're getting into the loop. As long as we're in the loop, we're going to be printing out a prompt saying, for example, server says guess a number from 1 to 10. And then we're going to prompt our user to type in a number. We're going to store whatever they type in into our user number string. And we're going to simply just send out that string to the server. We're going to use the out socket for that. We're just going to say print line user number. As long as we send the wrong number, we will be getting a message back saying guess a number. So this condition will be met as long as we're hitting the wrong number. And we will keep going through this loop. So as long as we're getting a sentence beginning with a guess, we need to be in this loop. As soon as we get something else, the other thing we can get is you got it. We are going to fall out of our loop. So we're just going to print out when that happens. Obviously, right after this bracket, we're out of the loop, and we can print out you got it. Let's save this and see if it works. As always, I'm going to run the server first, and then I'm going to run the client. Okay, let's play the game. So the server is saying you need to make sure that you're in the client console window. So the server is saying guess a number. I'm going to try 1. I haven't got it yet, so I'm going to just go from 1 to 10. I'm going to try 2, 3, 4, 5, 6, and I got it. It's 6. Of course, as soon as you get the right number, the next line of code for both the client and the server is going to be socket close. So the socket is going to be closed right after we get this message that we have hit the right number. Now, this was very basic, but hopefully it got you interested to continue to play around with the code. If you have any questions or issues, send me a message or just post it in the Q&A section. Since I've mentioned Wireshark several times in this course already, I've decided to create a bonus lesson to show you what the communication between our server and our client looks like in Wireshark. I'm going to run the first program we made, simple TCP, and there's only one change we need to make, and it's going to be on the client side. Instead of connecting to the loopback address, we're going to connect to the network address of this host. To see what that address is, I'm going to use command prompt. I'm going to say ipconfig, And here we have the address. It's 10.02.15. Let's type that in. Save the code. And then open Wireshark. I'm going to choose this adapter. And then I'm going to go back to Eclipse, run the server, and then run the client. When we open Wireshark, we can see our results, and I'm going to stop the capture. In the first few packets, we can see the typical TCP connection being established. So this is called the three-way handshake. We have SYN packet, and then SYN acknowledgement, and then another acknowledgement. The first packet that is actually a part of our protocol is this packet, and we can recognize it because it has this push flag turned on. When we look at what's in the packet, we can see this welcome message that we can recognize. And then when we look at the length of that message, it says 10 bytes. Let me show you what that 10 bytes actually is. It's actually welcome, and then new line, or it's like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's the 10 bytes we're transmitting in this particular packet. Now, regarding the push flag, when you go to the TCP part of the packet, we're going to look at the flags, and it tells us right away which flags are on. So it's the acknowledgement flag and the push flag. All the other packets don't have the push flag. They are anyway just SYN, acknowledgement, and FIN packets, which are a regular part of any TCP connection. Let's find our reply from the client. It's thanks. And that's the entire communication. So the session was opened, we sent welcome, and then we sent thanks back, and then we closed the socket, which initiated the termination of the TCP connection. In our first example, the one we called Simple TCP Program, we could only run one client at a time. In this example, our goal is going to be to enable several clients to talk to the server in parallel. We'll achieve that by using threads, and I'll try to explain the concept of multi-threading real quick right now. A thread in our example is just going to be an instance of the same application. It's the same code, same operations, same methods. We just run them separately for each new client. On the server side, we're going to have one main class where we're going to have our main method. The first thing we're going to do in this class is we're going to open the server socket. Then we're going to run an infinite loop where for each incoming connection, we're going to open a new thread. Now, I repeat, this is a very shortened version. We're going to go through the entire code later. For now, this is what threads look like. For every new client that connects to the server, we run a new thread. So this calls a run method in a server thread that we create for every new connection. So to sum up, whenever a new connection comes to the server, we create a regular socket by accepting that connection that's coming through the server socket, and then we create a thread for that particular connection. After that, we just go back to the loop and wait for the new connection to show up. All right, hopefully this will clear up as we go through the code. I'm going to open Eclipse. I'm going to create a new package and I'm going to name it simple TCP multi-thread. This time we'll need two server classes. One is server main and the other one is server thread. We'll copy the client class from our previous example because the code in the client is not really going to change. We're only changing the server. We're only enabling the server to accept several connections at a time. So I'm just going to copy the client into our new package. All right, let's get going. I'm going to start from the server main class. The first thing we're going to need is going to be the main method. And then inside our main method, we're going to have the try catch block again. We're familiar with that. We're going to do the print stack trace in the catch block, and in the try block, we're going to call new server main. Then we're going to create this server main method. It's going to be public. And the first thing we're going to need here is the server socket. We'll use 2020 for our port number again, and I'm going to press Ctrl-Shift-O to import all the necessary packets. Let's print out a message just so we know where we are when the program runs. We're gonna say port 2020 is now open. Now we need that infinite while loop. I'm going to add a comment here. You create an infinite loop by just typing true in the condition. So whatever happens inside the loop, we're always going to come back and do another run through the loop. So the point of this loop is to create a new thread for every new client that shows up. The first step would be to create a socket for every new client. So we're going to create the socket object, and we get the socket object when we accept a connection coming into the server socket. Again, I'm going to press Ctrl-Shift-O to import the socket package. And now I'm going to work on the thread. So now you're going to have to bear with me. I'm going to explain the code as I go, and some of it will only become clear later. So let's just type it in and see what happens. First, I'm going to create a server thread object, and I'm going to have to use a constructor from the server thread class. Now, since we don't have anything in that class yet, we're going to have this warning throughout typing this code, but don't worry about that. We're going to resolve that later. So here's our object. We're going to say new server thread, and we're going to forward the socket as the argument. Here's that error that I was talking about. We're just going to ignore that for now, and it's actually going to resolve itself. Now we're going to need a thread. Java already has a thread class, since threads are a pretty common conception. We're going to forward our server thread object as an argument. And then we're going to say thread start. Now what this means is whenever we run into this line, we're going to call a run method in the server thread class. You'll realize later on what that means, since right now we haven't built our run method yet. So let's go to our server thread class and get into it right now. Our server thread class is going to have to implement runnable. By the way, this could be done in a different manner, but we're going to use runnable. What runnable is, it's pretty much an interface and is like a template for an object that is intended to be executed by a thread. It defines a single method, which is run. We haven't defined it yet, but we are going to. And that run method is meant to contain the code that is executed by the thread. This is going to make much more sense when we run the code, so let's get into it and hopefully it will clear up. Now, before we add that run method, we need to create the constructor that I mentioned in our previous class. If you're not familiar with constructors, a constructor is kind of a special method that is called when an object is initiated. So a class constructor initializes instances or objects of that class. In our case, we need to initialize the object that we forwarded from our server main class, and that would be our socket object. We're going to define that object as private because we don't want other threads or classes to be able to access a socket in a particular thread. So it's going to be private socket, and then we're going to say public server thread. Now this method has to be public because we need to access it, or we need to call it from another class, and that class is the server main class. And here we are defining the object that is being forwarded. And then we're going to say this socket equals socket. We're using the this keyword because our objects are named the same. But if you're wondering which socket is which, you just need to click, or at least if you're using Eclipse, you just need to click on one of the objects and it's going to tell you which one of them is being referred here. So this is the socket we're talking about. This socket, this object, is going to become this newly defined object in our constructor. I'm going to press Ctrl-Shift-O to import the socket package, and then we can move on to our run method. I'm going to have to use override here because Java's thread class already has its own run method. So in order for us to be able to use our own run method, we're just going to use this override thing. Run is going to be public void run, and then we're going to have the try catch block inside of it. Our catch block is going to have the regular print stack trace, and our try block is actually going to have all of the code that defines the protocol for the communication between the server and our client. I'm actually going to be a bit lazy and copy that from our previous example. I'm gonna copy, no, I'm actually going to go to the first one. And I'm going to copy all of this. I'm going to edit this a bit. I'm going to add a printout here that a new client has connected. And then the server is going to say to the client, welcome, what's your name? I'm going to save that, and I'm going to go back to server main to check things here. Everything seems okay. I'm going to save that too. And then I'm going to open the client. The client is not going to be guessing any numbers this time, so we're going to delete all of this. Instead, we're going to just accept the message from the server. Print it out in our console. We're going to say and then we're going to store whatever the user types in into the same string. And then we're going to send that out to the server. That's it. That should work. I'm going to save this and then run it. We're going to run server main. So we're again running only the classes that have the main method. And then let's run our first client. I'm going to switch to the client's console. It's asking me what's my name. I'm going to say Luke, for example. And then I'm going to run another client. This time I'm not going to answer to server's question, and I'm going to run another client. So at this point we have two clients running. Let's check that out in the console. So we have client 3 here. Okay, so this is the second client and this is the third client. I'm going to type another name into the second client, and now my second client has disconnected, and then I'm going to type in something else into the third client. Let's say Laura, for example. All right, now all of my 3 clients have disconnected, but the server is actually still running. If we go to clients, it says terminated here. So I'm going to close this console, and then I'm going to close the third client's console, and I'm only left with my server's console. And I can see here that it's still running because I have this terminate button still available. I'm gonna click here, and now we're done. Now I can close the console for the server too. In this lesson, we're going to make a couple of changes to our code to be able to count the clients. Right now, every time we run a client, it just says a client has connected. So this is what we see at the server. If I run another client, it only says client has connected. I wanted to say client 1 has connected, client 2 has connected, and then client 1 has disconnected, client 2 has disconnected, etc., etc. Now, the reason why this isn't as simple as it may sound is that you may just think, okay, we're going to add a counter to server thread, for example, because this is where we print out client has connected. Well, it doesn't actually work that way, because every time a new client connects, we open a new server thread, which means that all of this code is run from the very beginning for every new client. That wouldn't work for us because if we were to define a counter here, for example, and say we want to start counting from 1, and then we increment it in this printout, for example, every time a new client connects, we would again start counting from 1. So that's not going to work. So the solution here is to count the new clients in the server main class. I'm going to delete this line since we won't need it, and then I'm going to stop all the clients in the server that we're running, and I'm going to go to server main. Let's save all the changes we made. All right, so we need some kind of a counter. I'm going to call it client number, for example, and that's going to be a private int. Then I'm going to create a method, and that method needs to be public since I'm going to have to access it from a different class. It's going to return an integer, so it's going to be public integer get client number. And then whenever I call this method, I want it to return client number incremented. Now, in order to later be able to access this method from our server thread class, we're going to have to use a server main object, and the type of that object is going to be server main. So I have to kind of forward this server main class to our server thread constructor. So you're just going to have to bear with me, and hopefully it will clear up as we move forward. So it's actually enough to type this in. This pretty much forwards everything that we have in this class, so we're going to be able to use this method from the server thread class. Let's save this and go to server thread. We're going to need the server main object. Its type is server main. And we've forwarded this in here, so we need to change the constructor. It's going to say server main, and then we need to initialize it here. All right. Now all we need to do is get the number from server main. So I'm going to create a new number. I'm going to say client number, server main, get client number. Now let's use that in the printout. Client number. And then I'm gonna use a dot, has connected. Let's see if we can add a number to this last message. Instead of socket is closed, I'm going to say client and then client number dot has disconnected. Let's save this and see if it works. I'm going to run server main, and then I'm going to run the first client. Okay, client 1 has connected, client 2 has connected, client 3 has connected. Let's switch to the clients. I'm just going to say A, client 1 has disconnected. Let's go to client 3, for example. This should be client 3. I'm going to say B. Client 3 has disconnected. Let's go to the second client. That should be this. Okay, seems that everything is working properly. I'm going to stop the server. and add something to the client as well so that the client knows what is his or hers number. We're going to say it here. We're going to say welcome. You are client number, and then we're going to say client number dot. You can now run this to see if it works and hopefully continue to play with it. As always, I'm going to save the code to the lesson, so that's where you can find it. To spice things up a little bit, I've prepared some fun examples. For each example, I'll read the task and then I'll show you what the result should look like. Anyway, you can always find the solutions attached to this very lesson. Task number 1. Whatever text we send to the server, server returns it in all caps. Let's see what that looks like. I'm going to run several clients right away. And I'm going to go to, for example, the second client, and I'm going to say hi. It returns it in uppercase, and then I'm going to say exit. It returns exit in uppercase, and then the socket for this client is closed. I'm going to go to the first client and I'm going to say something else. And then I'm going to type exit in all caps. It returns the same thing, and then the socket is closed. That was the first one. Let me close these, and then let's go to the second. Our second task is to send some text to the server, and then the server should revert that text backwards and send it back to the client. We end the program by typing in exit in the client. Let's see what that looks like. Again, I'm going to run server main first, and then one client is enough. Let's go to client's console. I'm going to type in hi and then blah blah, and then I'm going to type in exit. So this is what our program for the second task should look like. I'm going to close the client, terminate the server, and then close the server too. And I'm also going to close these classes. Let's look at our third task. It says that we need a client to connect to the server and then ask the client to guess a number from 1 to 20. Each client gets their own secret number to guess. All right, let's see what the solution looks like. I'm going to run server main, and then a client, and then another client. Okay, I guess this is my second client. Let's start with guessing. As soon as I guessed the number, I got "you got it" message from the server, and then the socket closed. So I can close this client, but I'm left with my first client, so I'm going to try to guess the number here too. Okay, this time it was 8. I'm going to close this client too and terminate the server. So this is what bonus example 2a should look like. Let's go to our fourth example, or 2b. This time all of the clients are going after the same number. So we need to generate one secret number, and you probably can guess it already. This time we're going to have to generate that number in the server main class. And then when we run clients, each of the clients is going to be chasing the same number. As soon as one of the clients guesses the number, the game is over. Let's see what that will look like. I'm going to open my 3 classes. I'm going to run server main once, and then I'm going to run 2 clients. Here I'm going to say Harvey, for example, and then I'm going to go to my second client, and I'm going to say Samantha, for example. Okay, let's get to the guessing part. Okay, I was beginning to think it was going to be the very last number. So Samantha got the number. Let's see what's going on with Harvey. If I try and guess a number here, it's already been guessed, and this is the message that I get from the server, that Samantha has already guessed the number. That's all the explanations you'll need. You can find the solutions attached to this lesson, but if you have any additional questions, just send me a message or post your question in the Q&A section. In this section, we talk about UDP socket programming in Java. First, let's remind ourselves of the difference between TCP and UDP. They are both transport layer protocols, and the main difference between them is that TCP requires a connection to be established before communicating, but UDP doesn't. From the perspective of coding network applications, in both cases we use sockets because we need a door through which we're going to send data. So both in TCP and UDP, we use a socket and we have port numbers. But the difference is that in UDP, there is no clear establishment of a connection. We just send every packet separately and hope for the best. Seriously, that's how UDP works. There is no flow control, congestion control, no sequence number, acknowledgement number, none of that. We just fill out these 4 fields and fill the payload with some data, send it out, and hope for the best. All right, let's create a new project for this. I'm going to do a right-click in the Package Explorer area, go to New Java Project. Let's call it Simple UDP. Now we're going to need a new packet. And then I'm going to create 2 classes. We're going to have a receiver and a sender. We're going to create pretty much the same program we created in our first exercise, where the sender will send a message to the receiver, and then the receiver will send something back, and that's going to be it. We're going to start from the receiver. The first thing we're going to need here is going to be, of course, the inevitable main method, and we're going to use try catch here too. In the catch block, I'm going to use printStackTrace, and then in the try block, I'm going to say new receiver. Let's go and create that method. It's going to be public receiver, and we need an exception here. We'll start from creating a datagram socket. As you can probably guess, this is similar to our server socket because we are defining our port number here. That's because even though we don't technically have a client or a server, we still need to reserve a port number in our operating system, and also an application, or rather a network application, has to have a port number. Regardless, there is going to be a lesson where I'm going to go through the code again, so don't worry, I will clear up the details later. I'm going to press Ctrl-Shift-O to import the datagram socket package, and now we can move on. The first thing I'm going to do is I'm going to print out receiver is running. And then we're going to need a scanner here, just like we had in our previous examples. I'm going to name it keyboard. And that's going to come from system input. And we're also going to need Ctrl-Shift-O here. Now comes the messy part. Since there are no streams in UDP, we have to pretty much build our own fields in the packet and also the payload. So the payload is sent as bytes, and the other fields, so let's just go through them. Source port, your computer knows which source port it's using, so we don't need to define that. But we do need to define destination port. We do need to define the length of the data. And then header and data checksum also is done by your operating system. So there are some tricky things here. So you're going to have to just bear with me. And I promise to explain all of this code in even more detail in a separate lesson. We're going to create a buffer here, and this buffer is going to be an array of bytes. I'm going to say bytes, and we're going to call that buffer. And we're going to say new byte, and the size of this array is 1500. This number is not accidental. It's called the MTU, maximum transmission unit, and 1500 bytes is the limit of how much data you can transfer in a single packet. Now we need to create a packet. Think of it as creating a frame where you're going to place your data. So it's datagram packet, we're going to call it packet, new datagram packet, and then we need the buffer in which we're going to place the data, and then we need buffer length. Since we have created an array of 1500 bytes, we could just say 1500 instead of buffer length, but let's do it properly. I'm going to press Ctrl-Shift-O to import the datagram packet package, and then we're going to move on to socket receive. At this point, we are receiving the message from the sender, and we want to place that message into our newly created packet. I'm going to add a comment here. And now we need to extract a string from that message. So our message is in this object, and the message is actually in this buffer part. We want to create a string. We're going to call that string message, and we're going to say new string. Take the data from buffer and then trim that data. We're using trim here because there's a huge possibility that the sender typed in something much shorter than 1,500 bytes. If you remember from one of our previous examples, welcome was only 10 bytes. So we're using this method to get rid of any unnecessary data that comes after our sender's message. Now that we've got the string, there's nothing stopping us from printing that string out. We're going to say received and then display the message. At this point, we're pretty much done with the receiving part. Now we need to focus on the sending part. In order to know where to send our response, we need to get the IP address of the sender and the port number that the sender used. Here I'm talking about the source number that the sender used, only this time we're going to use their source number as our destination number. This data is stored in the packet itself. I'm going to say init address, sender's address, and then get that from the packet. And then sender's port is an integer. Get port. Control-Shift-O to import the packages, and we can focus on the sending part now. We want our user to enter their message. And then we're going to store their message into our message string. We're going to say keyboard. Now we need to switch that message or that string into bytes. We're going to fill our buffer with that message by saying message and then get bytes out of my message. Now we need to fill out our packet. We're going to create a new packet. And what we need is the buffer. Our message is actually in the buffer. We need to say what's the length of our data. We need to say we need to say what's the IP address where we're sending the message, and also what's the port. All there is left to do is to send out that packet. We're going to use socket send, and then we're sending our packet. I'm going to add a printout just to track where we are. We're going to say sent and then display the message that we sent. That's it for the receiver. Of course, to be able to test this program, we need to create the sender. So we'll do that in the next lesson. See you there. As promised, in this lesson, we're going to go through the sender side of our simple UDP program. Let's get our main method out of the way. Again, it's going to have the try-catch block. We're going to use ePrintStackTrace in the catch block, and then new sender in the try block. We're going to define our sender method here. And then just like on the receiver side, we need our socket. We're going to call it socket. And since this is a client socket, we don't need to forward any port numbers. I'm going to press Ctrl-Shift-O to import all the necessary packets. And then I'm going to create a scanner. Again, Ctrl-Shift-O. And here we can start with the sending and receiving processes. So this is a sender. So the first thing this program is going to do is it's going to send a message. So I want to prompt the user to type in the message that they want to send. So I'm going to say enter your message. And then I'm going to store that message into message string. And then we need to move that string into an array of bytes. We're going to call that buffer. And we want to get the bytes out of our string. Next, we're going to define our packet. Again, it's going to be datagram packet. We're going to name it packet. And we're going to say new datagram packet. And this time we're sending buffer where we have our message, buffer length, the IP address. We're going to use get by name, and then instead of typing localhost, we can do that too. We're going to type the IP address. And then after that, we need the port number of the receiver. And that's pretty much it. That's our packet. The only thing I'm missing is Shift Control O. Now we can just send our packet through the socket, and I'm going to print out a message saying, all right, that was the sending part. Now we can focus on the receiving part. I'm going to create a new array of bytes since the previous one has been filled. So I'm going to say new byte, and the length is going to be 1500 bytes. And then I'm going to define a new packet. The packet needs to have a buffer, and we need to know what's the length. And right after that, I'm ready to receive my packet. So I'm just going to say receive, and then we're going to store the packet that we received into our packet object. The only thing left to do now is to transfer the data from our buffer into our message string. I'm going to say buffer here, and then we need to use that trim method. And then we can print out what we received. That should be it. Let's save this and then try it out. I'm going to run the receiver first. And then I'm going to run the sender. I'm going to say hi. Okay, so I can see at the receiver that they have received my message. I'm going to say bye, and this is it. Both the receiver and the sender are terminated because we have reached the end of our programs. And as you can notice, we don't have the socket close here. That's because we don't have a socket open. And that is pretty much because in UDP, you don't have a connection that is established before you send any data. So in this program, we have pretty much sent each packet on its own, which is why the code looks like this. In the next lesson, I'm going to explain it even further, and we're going to add something to make this communication go on. So we want these two programs to be able to continue to communicate, and we'll see how that's done in the next lesson. As promised, in this lesson, we're going to go through the code again and explain it with more detail. We are going to edit the code a bit, so I'm going to add a new package. I'll name it simple UDP 2. And then I'm just going to copy these two classes into this new package. I'll close the previous two classes and open the two new ones. The thing we're going to change is we're going to allow these two to continue to communicate indefinitely, but only the sender will be able to enter their message. The receiver is going to just send, let me see, the receiver can just send OK. This means that I don't really need these lines. I don't need this one, and I don't need the scanner. But in order to allow them to communicate indefinitely, I'm going to have to add an indefinite loop, and I'm going to add it right here. It's going to be while, and the condition is going to be true. And then I'm going to close this loop right here. Now I want to format this better, so in order to do that, I'm going to select the code that I want to shift to the right, and I'm going to press Ctrl-Shift-F. F is short for format, and this is what I get by using it. So I'm happy with this. I'm going to save that and move to the sender. We need to add the same loop here, and this is where we'll put it. It's going to be while true, and we'll close it right here. We're going to format this too by pressing Ctrl-Shift-F. Okay, that's it. I'm going to save this and test if it works. Let's run the receiver first. Receiver is running. That's a good sign. I'm going to run the sender now and enter something. Hi, and then receiver says okay, and then I'm gonna say bye, for example, and receiver again says okay. Now ideally we would have some kind of verification here, and we would check what did the sender send. For example, if they send bye or quit or exit, we could break from our loop and end the program. But I'm going to leave that to you, since we've already done something similar in our previous examples with TCP, so you can do the same here. But since this is UDP and there is no established connection, we can simply just terminate the sender and then close the console, and then terminate the receiver and close that console too, without any consequences. We didn't get any errors, we didn't get any exceptions. We were just able to close these two programs without anything really going wrong. That's because, as I've already mentioned, there are no sessions established between the two. That's because each packet is built and sent separately. And additionally, we're using UDP, which is pretty much a best effort protocol. So even if a packet is not delivered to its destination, no worries. That's how UDP is expected to work. All right, let's go through the code. I'm going to start with the sender, and hopefully you already get the whole point behind the main method. This is, as I said in our previous TCP examples, an entry to our application. And then we have the try catch block. We try to execute some code in this block, and then if something fails within that code, we are thrown to the catch block. In the catch block, we've always used this method print stack trace, which pretty much just prints out anything that went wrong in these red letters in this console area. So in our try block, we are initiating a new sender. And the first thing that happens there is we create a datagram socket. This socket is very similar to the regular socket we used in our TCP examples. It's just a door that we use to throw out the data and receive the new data that's coming in from the other side. Then we have created a system input scanner that we used to get the data that our user is typing in to be sent to the receiver. So this is where we have used our keyboard scanner to get the message from the user and then send that message through the socket. Regarding the while loop, I added it in this lesson, so you get why I did that, but let me explain why it's in this place. I added it here because everything that happens in the body of the loop repeats itself all the time, and I need these things to repeat because this is the communication between the sender and the receiver. For example, these two things don't have to happen every time we want to exchange messages between the sender and the receiver. They only happen once. So we need to open a socket only one time. We have defined our keyboard scanner only one time. All of the other things do need to happen every single time these two want to exchange messages. Every time the sender is sending a message, we want to print out, enter your message to the user. And then that user enters their message and we store that message into our message string. Then we translate that message into bytes and we store those bytes in our buffer object. Then we take that buffer where our message is stored and we put it into our packet. So what we need to put into the UDP packet is the payload itself. So the payload is the message. That's the useful application data that we are transferring between the two applications. Then we need to specify the amount of our data. That's the length. And if we look at the UDP header format, this is the field I'm talking about. So this is the length field. And then we are specifying the IP address that we're communicating with, and then we're specifying the destination port. As soon as we have formed that packet, we can send it out through our socket. This line below is just a printout for our own console where we are saying this is what was sent. And then the rest of the code is the receiving part. So we needed all of this to send a packet, but we're going to use all of this to receive a packet. Let's go through it line by line. Here we are using the same buffer we used to send a message, and keep in mind that at this very point, this buffer actually has this message in it. So that is why we are creating a new array for this very object. That's because we are going to fill it with the data that we are waiting for. This is the data that is going to be in the packet that we are receiving here. Again, we are using an existing object, so this packet already has some data in it because we used the same object to send that message that our user entered. So now I am creating a new packet that is going to be empty and is going to be ready to receive the incoming packet. And that's exactly what I do in this line. I am looking at the socket and I am saying, okay, I'm expecting to receive a packet right now. When it comes, put it into this new object. So this object isn't new. It was created earlier to send a packet, but I have just redefined it in this line here. And so now it's empty and it's ready to receive the new packet. As soon as I have received the packet, I'm going to extract the string from the packet. So that string or that message is inside of a buffer. So I want to use this new string to again do pretty much the same thing I did here. I want to reuse this message string, but I'm going to have to extract that message from my buffer. Additionally, when I extract the message from the buffer, I need to trim it because, as I mentioned while we were creating these two classes, this buffer is 1,500 bytes long and the message that I received may be shorter. So this trim method is used to cut all of that excess data. And then again, the next line is just a printout of the message that we received. All right, that's the sender. Let's go back to the receiver. The main method here is again the same main method we've used throughout this course, so I'm going to skip that. The first thing we see is the datagram socket. It's similar to the sender datagram socket, only at the receiver end we have defined the listening port number, and then we've used this printout saying receiver is running. This is just for tracking purposes to see if we've gone through this line of code correctly. And then we get into our loop. Here we have the receiving part and it's very similar to what we have in the sender. So I'm going to just skip that. The only difference we have is this part. At the sender, since the sender is the first one to send a packet, we had to define the destination IP address and the destination port number. But since the receiver is just replying to the sender, the receiver can just pull out the sender's IP address, so the source IP address from the packet, and the sender's source port number. So here, the receiver is getting that information from the packet and then is using that same information to create the new packet that it's going to send back to the sender. That's pretty much everything that happens in this part. And then we're left with only the printout, which is, as always, only giving us a notification in our console part to let us know where we're at and what is happening, and in this case, what was sent to the sender. That's it for this lesson. If there's anything else you'd like to know or something you think I could help you with, send me a message or post it in the Q&A section, and I'll make sure to try and help you if I can.